Here we go. We're going to go ahead and work on the solving the warm-up. Good, Jalen. So here we go. Subtract 1. Remember, it's just like solving with an equal sign. So I've got 3x is less than 6 divided by 3. X is less than 2. And then they want me to graph it. So let's put my graph here, I guess. 2, 3, 1. It's open at 2 and it's less than 2, so it goes this way. And then interval notation would be negative infinity to 2 with a parenthesis because 2 is not included. So there's 1. 2, subtract 3, and I get negative x is greater than or equal to 9 divided by negative 1. So x is less than or equal to negative 9. So my graph would be negative 9, negative 8, negative 10. Closed at negative 9, and it's less than negative 9, so it's still going that way. So I've got negative infinity to negative 9 included. Whew, okay. And then, let's see. Multiply by negative 3. So I've got 2t minus 9. I multiplied by a negative number, so my inequality sign switches. Negative 21 plus 9. 2t is greater than or equal to negative 12. Divide by 2. T is greater than or equal to negative 6. So if I was to graph this, I would have, let's see, negative 6, negative 7, negative 5. Solid on negative 6, and then it would go this way. So my interval notation would be, my least one is negative 6, and it's going to positive infinity. Okay. And then, okay, distribute. So I've got 19 minus 2x minus 3 is less than or equal to 2x plus 6 plus x. So that gives me negative 2x plus 16 is less than or equal to 3x plus 6. Okay, so add 2x minus 6, and I get 10 is less than or equal to 5x. Divide by 5. X is less, oh, nope, not x. 2 is less than or equal to x. So my graph would be, oh, I'll answer that question in just a second, Jalen, okay? So 2, 1, 3, and it's open, closed on 2, and it says x is greater than 2, so it would go this way. So my interval notation would be 2 to infinity. Okay, so why does it close? Why does the sign flip on number 3? So remember Ethan, Lucia, and Leslie. I think Leslie was already in, though. Lucia and Ethan. So remember the rule yesterday was just one rule that changed. It said if I multiply or divide, multiply or divide by a negative number, then my sign changes directions. So most of the time I'm just dividing by that negative number, but in this case I multiplied by a negative 3. So when I multiply by that negative here, this negative 3, my sign switches directions. Does that make sense? So if I multiply or divide by a negative number. Are you okay with that? Yep. Okay, great. Awesome. Okay, so yeah, we just don't multiply that often. That's why we don't think about it. We mostly divide, but if we do multiply by a negative number, I still have to flip the sign. So that's all. Okay, there we go. Any other questions on the warm-up? And then I need to pause just for a second, you guys, because I forgot to do something this morning. It'll just take me a second. Okay. It is so cold. Cannot believe how cold it is right now. Of course, it's probably going to get colder, but you know. Okay, so here we go. With our definitions. So a compound inequality. A compound inequality is two. There we go. Let's try this again. Two inequalities, Nequality, inequalities joined by the word and or the word or. And some examples are, let's see, examples. X is less than -3 or X is greater than 0. And then we have would be X is less than 5 and X is greater than 3. Sometimes you won't see the word and, just so you guys know, and is not always used. Sometimes they just use notation for the word and you will see it written like A is less than X, which is less than B. Okay, or it could be the other way around where you could say, let's do that. B is greater than X, which is greater than A. So sometimes it's connected that way, and those ones are the and in the equations. And that's usually how and is written. They usually don't use actually the word and. They just kind of combine it into one statement that with two inequalities in there. So that's usually how they do the ands. The ors will always have an or in between there. It's either this or this, one or the other. Okay, so the word intersection. Intersection, yep, I didn't write on there, of two sets, A and B, is the set of all elements that are common to both. Both A and B. So, if I was to draw a picture of it, I'm going to just kind of come over here to the side. Oops, sorry, I still want you guys to be able to see what it says. If I should draw a picture of it, like using, I I guess you would say a Venn diagram, and that's what it is. So if I have set A here, and then I have set B, whew, my circles do not really look like circles, sorry. Set B here, the intersection of that is the part where they overlap, this part right here. Okay, ooh. And we would use notation like that that would say A intersection B. It's an upside down U. Okay, an example mathematically would be if I have the set 1, 2, 3, 4, 5. Oops. And I want to find the intersection between that set and the set of -2, -1, 0, 1, 2, and I think I have another number in there. Oh yeah, 3. Okay, so the intersection is everything that is in both sets. So they have to be in both of them in order to be the intersection. So the answer to this would be the set 1, 2, and 3, because those are the only elements that are in both set A and set B. So an intersection is what's in both sets. Okay, is there any questions on that? We're going to do some more of this, so. Okay. And then our last vocabulary word is the word union. And a word union is the union of two sets. We're starting out the same way. A and B is the collection of Sorry, I'm laughing at my writing. It's so bad. Collection of elements belonging to A and or B. So in this one, if I'm going to draw my little Venn diagram over here, here's A, here's B. The whole thing is my union. So this would be A union B. Okay, and for union, they use the symbol upside right U. Okay, so my example on this one, I have a little bit more room here. If I have the set 2, 3, and 4, and I want to find the union of 3, 5, and 7. So union is everything that's in both sets. So everything that's in both sets has to be in both sets. So it's everything. So that means it would be 2, 3, 4, 5, and 7. And I only have to write it once. So like there's 3 in both sets. So I only have to write the 3 once. There's a 5, there's only a 3 in both sets. Okay. So I only have to write the 3 one time, but I do have to write everything that's in both sets. That's what a union is. It's everything. And intersection is just the elements that are in common. Okay. So we're going to do a couple practices of those. Can I go on? Does anyone need more time to write? Oh. Why are you not popping up there? There we go. Okay, it looks like no one's saying they need more time, so we're going to go ahead and move on. Okay. So it says find the indicated intersection or union. Remember, I'm going to write this up over here. Upside down U is an intersection. And a right side up U is a union. Okay? So when I look at this, I need to look at what it's in between and what it is. Oh, and there's, so, okay, I'm getting ahead in my head. Sorry. So I want to look at what's in between the two sets to see if they want me to find an intersection or a union. And then I need to find those two things. Okay. There's one other symbol in here that we haven't talked about yet, and it's this one here. It looks like this. It's called the empty set. That just means there's absolutely nothing in there set. It's an empty set. There's nothing in there. So that's what it means. So it's like a number 4. I'll explain it more when we get there, but it just means there's nothing there. It's empty. Okay, so let's go ahead and go to number 1 here. And it wants me to find an intersection. Intersection is the elements that are in common. So there's an M in both of them, there's an O in both of them, and there's a P in both of them. So that is my intersection. So it would be the set MOP. Okay. All right, no questions yet. The upside down U is a union, so it wants everything that's in both sets. So I need everything that's in both. So I need and you usually go in order. So smallest to greatest, always when we talk about sets, we always go smallest to greatest. If it's letters, we're going to go alphabetically. So I think we've got U, V, X, Y, and Z. And I think that's all. Okay. The fourth one is an intersection again. So I want the ones that are in both sets. And let's see, 3, 9, 12. 5, 10, 15. And there's nothing in either set that's an intersection. There's no intersection at all in this. If you can see, there's 3, 6, 9, 12 in the first set, and then 5, 10, 15 in the second set. There's no overlapping of this. So my answer for this one would just be the empty set. And you can't put that in the chat box when we're talking about that, so you just spell out empty set. The empty set. Ooh, if I can spell. The empty set. Okay. And then on 4, it wants a union. So it wants everything that's in the set 1, 3, and 5 and everything that's in the empty set. Well, since there's nothing in the empty set, it's only going to be the set 1, 3, 5. Okay. That's it. Whew. Okay, so I'm going to have you do problems A through D. Thanks for telling me I'm okay. It's been a long week. I'm glad it's Friday. So our intersection of the first one is everything that's in both sets. So that means I'm going to start with 0, then 5, then 10, then 15, then 20. Okay? And then the B is A was the union, B is an intersection. So what's in both terms? So I've got a B here, and I've got a D. So it's the set B, D. And then C is a union again. So what's in both sets? X, Y, and Z. And then D is the intersection between 1, 3, 5 and the empty set. Well, since it's an empty set, there is no intersection, so it's just the empty set. Okay. So, now we're going to, let's see, what does it say? Graph and write the interval notation for each compound inequality. Okay, so we're going to graph this, and then we're going to write it in interval notation. Okay. So on this number line, I'm going to need a few, it might need to be a little longer, and I'm going to need probably a few more points on here because I need to go from -8 to, -2 to -8. So that's actually not too bad. So I'm going to have -10, -8, -6, -4, -2, and 0. So I made it a little long. There we go. Okay. So again, my endpoints are the same. So if it's greater than or less than, so let's come over here for a second. So if it's less than or greater than, I have an open point. If it's less than or equal to or greater than or equal to, I have a closed point. That hasn't changed. So that stays the same. I have seen people even on graphs use, instead of the open dot and closed dot, which, by the way, when you're doing any testing or anything, it needs to be the dots. But I have seen people use parentheses and brackets on those points. So when you go to write it in interval notation, it's just, it's already there for you. I have seen people do that. So at -8, I have, let's see, it's just an open point. I'm going to do this in a different color. It's an open point. And at -2, it's a solid point. Okay, so when I'm reading these compound inequalities, especially this one, I always read from the variable out. So I know that normally we read math from left to right, just like we read words and everything. But this is the one occasion where I kind of, I'm like, let me do this a different way. So I'm going to start at my X, and I'm going to read this way, and then I'm going to start here and read this way. So I just sometimes think it makes it a little, at least for me, it makes it a little simpler. If I start at my X and read out, you guys don't have to, but it always helps me when I'm trying to figure out which way my arrow is going. So this says X is greater than -X. -X, wow. X is greater than -8. So if I'm reading it this way, X is greater than -8. So greater than -8 is this way. And then this one says X is less than or equal to -2. So that means it's this way. So my graph is only in between here, because it's got to be bigger than -8 and less than -2. So it can't go on either side of them. So it's just like this little dumbbell looking thing. That's it. Okay. And then interval notation would be open at -8 to -2 included. Okay, I think that's all they wanted me to do. All right, so let's go to the next one. We're going to do the same thing. I'm going to leave that small enough so you guys can see it. Okay, so I've got my number line. Ooh. Let me try. Wow. Let me try this again. Yeah, it's a little better. Okay, so I need to go between -2 and 1. So -3, -2, -1, 0, 1, and 2. Okay, so at -2, we have a solid dot. And at 1, I've got an open dot. And then it says X is less than -2, so that's going this way. And X is greater than 1, which is going this way. Questions so far? Are we doing okay? So my interval notation will look like this. It'll say -infinity to -2, union 1 to infinity. Because my answer is everything in both of those sets. That's why we use the union. Okay. Good job, you guys, so far. No questions? Is this okay? It's not too bad? Are we okay? All right. So this one, I'm going to go, let's see, -4, -2, 0, 2, 4, and 6. And I have an open circle at 2 and an open circle at 4. Beautiful. So x is greater than -2 and less than 4. So it's in between here. And my interval notation would be -2 to 4. And then, let's see. We've got -2, 0, 2, 4, and 6. So at 4, I've got an open spot. And at -1, I have an open spot. So x is greater than 4. And x is greater than, or x is greater than -1. Okay, so this one to write in interval notation is a little tricky. So I'm going to go to -2 to 4. Neither one is included. Joined with 4 to infinity. Because it's everything going to the right except for 4. Okay, is there any questions? Okay, so now it's going to be your turn to try this. Do I need to leave some of the graphs there? So I'm just going to draw my number lines. I guess I could have done that well. You guys were doing this. So, -8, -6, -4, -2, 0, 2. So a solid dot on -6, a solid dot on 0. X is greater than -6 and less than 0, which means it's between here. So my interval notation for my domain would be -6 to 0. Brackets. Okay, and then for B, let's see. 0, 1, 2, 3, 4. And then we've got open at 1 and open at 3. X is greater than 1 and less than 3. So again, it's between here. So my domain would be 1 to 3. And then here, let's see. It's a lot of numbers to write out. Let's just do -4, -2, 0, 2, and 4. And then we've got an open dot at 2. And it's greater than 2. And t is less than -3. So I've got an open dot at -3, and it's less than that. So my interval notation should be -infinity to -3, joined with 2 to infinity. Okay, and then D, 1, 2, 3, 4, 5, 6. Open at 2, t is less than 2. Oops. T is less than 2. and t is less than 5. Great. So that means my interval notation is going to go from negative infinity to 2, joined with 2 to 5. Okay. Yeah, like that, exactly. Okay. Questions? Is everyone okay? Or the people who want to talk to me okay? It's okay. You guys will just get credit for this. Okay, great. Go. So now we're going to solve. It says solve and graph each. It doesn't even say, by the way, to write in an interval notation, but we're going to, because I have to tell you, on your checkpoint, the only way to check to see if it's right is interval notation. So we're going to write the answer in interval notation. I hope you guys are okay with that. Even though the directions say not to, I should have changed that today, but I didn't get to it. I forgot. So for number 1, there's actually 2 different ways I can do it. I can do it, I can leave it in this form and do it. The problem is some people forget that I have 2 signs. So whatever I do on, the rule is whatever you do to one side of the equal sign, you have to do to the other. Well, that applies to inequalities too. But if I have 2 inequalities, I have to do it on both sides of those inequalities. And that's where people sometimes forget to do. They forget to do it on both sides, and they only do one side and then leave the other side alone, and then you get the answer incorrect. So one way you can, one thing you can do to fix that is I can take this inequality, and why I left the paper so big is I can do this. So I can take this, -1 is less than x minus 3. And then I can take this one. Oh, so sorry. Let's see, is it going to do that? Oh, it erased everything. Okay, so we'll try this one more time. I can take this side, right, and write that. And then I can take this side and write it also. So I just have 2 different inequalities. Then I have x minus 3 is less than 5. So no matter what way I do it, I still have to do two equations, because I'm going to have 2 separate answers. This way, if I separate it out, sometimes it's better for people to see, oh yeah, I have 2 equations I have to do. If I leave it in the form that the equation's originally given to me, sometimes it's a little harder to see. But I'm going to solve this first one both ways so you guys can see how it's done both ways, okay? So if I separate them out like I did over here, I'm just going to solve like I did yesterday, I think, when we were in class yesterday. So I'm going to add 3 to both sides, or all sides here, and I get 2 is less than x, and x is less than 8. Okay, so then I'm going to graph it. And we've got 0, 2, 4, 6, 8, wow, 10. So at 2, I have an open spot, and at 8, I have an open spot. X is greater than 2, and x is less than 8, so it goes in between there. Okay, so there's my graph. So I like to choose, because I'm going to be honest, I really don't like writing extra. I mean, I'm kind of like you guys. I don't like writing extra if I don't have to. So I tend to leave my equation like it is here, and I just work from here. And you can drop like your little dotted lines. I've seen people do this, so you could remember that there's multiple sides that I have to work with here. And I wanted to get the x by itself again, so I'm going to add 3. Where do I add 3 at? Well, on all sides of those inequalities, I have to add it in 3 places this time, not just 2, because I have an extra inequality sign. And that gives me 2 is less than x which is less than 8, which is this exact same thing as what I got right here, and it'll be the exact same graph as I get right here. Okay, so it's all the same thing, it's just different. The problem is you have to remember, if you do it the second way, to do it on all sides of the inequality. So I can't stress that enough. Do it on all sides of the inequality. And then if I was to write this in interval notation, right, it would be from 2 to 8. Okay? So if that's okay. For number 2, it already gives me 2 equations, so I just have to solve both equations. Okay, so I'm going to add 7 to both of them, and I'm going to solve them individually. So 2t is less than or equal to 12 divided by 2. T is less than or equal to 6. And then the second one here, we're going to subtract 5, and I get negative 2t is greater than negative 2. Divide by negative 2. T is less than 1. So remember, I divided by a negative number, so that inequality sign has to switch directions. That's the one rule, the one thing that's different than with equal signs. If I multiply or divide by a negative number, I switch the direction of the sign. So then I'm going to graph this. So let's see, what do we have here? We have 1 and 6. So I'm just going to do 0, 2, 4, 6, 8. And it's closed at 6. And it's open at 1. T is less than 6. So T is less than 6. And T is also less than 1. Okay, so my answer would be, in interval notation, negative infinity to 1, joined with 1 to 6. Boom. Okay, questions? Are we okay so far? All right, so we have one more to do here together. So the first thing, I'm going to just leave this one, instead of writing it as 2 separate equations, I'm going to leave it as 1 and make sure I do everything on all sides. So in order to get rid of my fraction, I'm going to multiply by negative 5. Multiply by negative 5, right? So those 5s go away. And then I get 10. I multiplied by a negative number, so my inequality sign switches. I have x plus 2. My inequality sign switch, both inequality sign switches. And then I've got negative 30. Is that right? 10, yep, negative 30. So then I'm going to subtract 2 from both sides. From all sides, all 3 sides. So I've got 8 is greater than or equal to x, which is greater than or equal to negative 32. So now I'm going to draw my number line. Here we go. And I'm going to go 0, 8, 16, 24, 32, and 40. Okay, so at 8 I've got a solid circle. Oh, I went the wrong direction, didn't I? Okay, let's try this one more time. Oh, okay. Let's try this one more time. Okay, so I think I'm gonna have to start with 16, 8, 0, negative 8, negative 16, negative 24, negative 32, and negative 40. There we go. Ooh, okay, so 8 is solid, negative 32 is solid. So x is less than 8 and greater than negative 32, so it's between here. So my interval notation would be negative 32 to 8, or my domain, if that's what you want to think of it. If it's easier to think of it as your domain, think of it as your domain, negative 32 to 8. Okay, so here you go. You've got 2 problems to solve. Go ahead and work on this problem here. So I think that, yes, Yoni, that one's right. Now it's right, yeah. Okay, so I'm going to subtract 5 from both sides here, and I get negative 3a is less than or equal to 3. Divide by negative 3, and a is greater than or equal to negative 1. Then subtract 1. 2a is greater than 6. Divide by 2. A is greater than 3. So to graph this, let's see. Oh, we're odd, so that's good. Negative 3, negative 1, 1, 3, 5. I've got a closed dot on negative 1 and an open dot on 3. And a is greater than 1 and greater than 3. So my domain would be negative 1 to 3 joined with 3 to infinity. Okay, and then for number 2, or number B, whichever it is, I'm going to subtract 2 from all the sides. I get negative 5 is less than or equal to x, which is less than 7. So if I'm going to graph this, I've got negative 7, negative 5, negative 3, negative 1, 1, and I need a whole bunch longer line. 3, 5, 7, 9. There we go. And I've got a closed dot on negative 5 and an open dot on 7. It's greater than 5 and less than 7. So it would be negative 5 to 7. Questions? Remember, you have to subtract it from both sides of the inequality. So make sure that you do it from both sides of the inequality, okay? Okay, so really quick, oh, I'm going to pause this now.